Okay, I think that is us live. Hey all, hope you are doing well and welcome to the second installment of our office hours, which is Intro to Apache Arrow. We'll get started in just 30 seconds or so. We'll see if anyone turns up for this one. Just in the meantime, what we'll sort of announce at the moment is we actually have a building a hybrid training workshop tomorrow. So if you're interested in learning how to use InfluxDB OSS with InfluxDB Cloud, definitely come along. You can find that at 8 a.m. Pacific time, and that's also 9 a.m. Also 3 p.m. GMT. I should get that right. I should get my own time zone right. But without further ado, let's get started and discuss exactly what intro to Apache Arrow is. So if I quickly jump over. So the idea for this office hours is to sort of break into what Apache Arrow is, but as a byproduct of that, we'll also discuss what Parquet is and Flight SQL, as we will be using them within our examples, and they're all representative within Apache Arrow. Using Apache Arrow by itself is interesting, but it becomes extremely interesting when we start combining it with other technologies such as Parquet and Flight SQL. So what exactly is Apache Arrow, Parquet, and Flight SQL? Well, they're all part of the Apache software foundation. And so we have Apache Arrow, which is an in-memory data format, Parquet, which is an on-disk data format, and then Apache Arrow Flight SQL, which is a standardized transportation protocol. So let's delve into each one of these and see what each project has to offer and how they operate within a larger ecosystem. So let's first start off with Apache Arrow. So Apache Arrow provides a cross-language in-memory data format designed to improve the performance and efficiency of big data processing. It does this by providing a standardized way to represent complex data structures in flat memory format, allowing data to easily be passed between different processing frameworks and languages. So if you look at this table on the left here, you can see the standard or traditional way a columnar structure is, so a tabular structure is represented in memory. You can see each row is represented one by one. So we have our session ID, our timestamp, and our source IP. Now, if we look on the right-hand side, we can see what a arrow memory buffer looks like. This shows that we represent each column initially as each section of memory. The cool thing about this is this is vastly more efficient for our modern day CPU and GPUs to process tabular data. And the benefit of doing this is it enables efficient data sharing across different systems and languages without the need for expensive data serialization and deserialization. So as an example of this, you can see Arrow versus Pickle processing a large number of NumPy arrays, which you can see in this chart here. The fact that the array bars for deserialization are barely visible, which you can see here, is not a mistake. This is the consequence of the support for zero copy reads, which is largely comes from the lack of in-memory movement from Arrow. So just to clarify here, so Pickle is another way of processing large numbers of NumPy arrays. We can see the time in seconds it takes to serialize and deserialize, whereas Ray is represented, but is representing Arrow in this case. And you can see we have a vastly lower serialization time and almost trivially none deserialization time for those NumPy arrays. So as well as this, Arrow supports a range of programming languages, including C++, Java, Python, and R, and is increasingly becoming the standard way of representing and processing data in the big data ecosystem. So moving on from this, let's now talk about Parquet. So our Parquet is an open source file format designed by Doug Cutting, the creator of Hadoop. It was specifically designed for columnar storage to enable efficient and high performance data storage and processing. Parquet is designed to store structured and semi-structured data in a way that allows for efficient, compression and encoding of the data, which you can lead to significant improvements in data storage and processing. You can see this from a side-by-side comparison with a CSV stored on S3. So if we look at this table down here, if we take a CSV file that's stored on S3, that's 1 terabyte in size, takes around about 236 seconds query runtime. The amount of data that needs to be scanned during that query is 1.15 terabytes, and it costs around about $5.75 to keep on an S3 bucket. Now, if we then had that same amount of data, but within an Apache Parquet format, so that's the equivalent data, but in the Apache Parquet format, we reduced our storage size down to 130 gigabytes, which is about 87% less. Our query runtime is only 6.78 seconds, which is 34 times faster. And the data scanned is 251.1 gigabytes, which is 99% less data scanned. And it only costs us 1 cent to store on S3, which is a 99.7% saving. So you can see why so many big data companies, especially data warehouse providers, are now swapping to Parquet as their storage file format for tabular data. And this is not to say that not other big data processing frameworks are also using Parquet as well. Apache Spark, Apache Hive, Apache Impler are all allowing use of the Apache Parquet files, so basically providing read algorithms and write algorithms back to be able to utilize this data. So the reason why Apache Arrow and Apache Parquet relate is Apache Arrow's goal is to be essentially the in-memory representation of Parquet. It's meant to be the standardized way of representing tabular data within memory, whereas Parquet does this on disk. And so this is why both Parquet and Arrow are powerful cousins to each other when utilized in a solution. So lastly but not least, let's discuss exactly what Flight SQL is. But to understand Flight SQL, you first need to understand what the parent technology Arrow Flight is. So historically, data transfers from DBs have been row-based. You may be familiar with ODBC or JDBC. When big data providers realized columnar storage equaled good data transfer hadn't caught up, leaving columnar to be converted to row-based transfers, which left huge bottlenecks when converting from columnar to row-based to columnar again in your client-side application. What Apache Arrow Flight did is it was an open source framework designed to solve this issue by providing an efficient and high performance data transport between applications leveraging the columnar format. The problem with Flight is that it's just an efficient transportation protocol with no standardized way for querying, for query execution and catalog access. So in came Flight SQL. So Flight SQL became part of the Flight ecosystem, which provides a SQL interface for querying data over Flight. So the benefits of this was Flight SQL provides a standardized query interface, which most developers are familiar with, but also allows you to leverage the columnar performance of Flight, which led to significant improvements in query execution times and overall system performance for big data workloads. So this is still in experimental mode, but it's a really amazing step forward for providing an efficient way of querying columnar data from columnar represented databases. So how does this all relate to InfluxDB? Well, why are we talking about these projects, Apache Arrow, Parquet, and Flight SQL? Well, InfluxDB IOX is built on all three of these technologies, Apache Arrow, Parquet, and in this case, Data Fusion. So this is a Thrust framework enabling Flight SQL for InfluxDB IOX. And the cool thing is you can actually leverage these technologies yourself within the client libraries. So the Arrow-based client libraries enable you to utilize the same performance in your own application and provides powerful integrations to other libraries that you know and love. So let's take Python, for example. We can now integrate with Plotly, CAT, anomaly detection toolkit, Apache Spark, in a much more performant manner using the Apache Arrow ecosystem. It also is providing us compatibility with enterprise-grade platforms such as Tableau, Grafana, and RapidMiner as well. So moving on from that, let's delve a little bit deeper and do a 101 tutorial. Let's get our hands dirty with some code and have a look at how we can start coding with Apache Arrow. So we're going to be using Python for this to keep it simple, but the overall format or the overall data, the concepts that we'll be discussing will be representative whether you're using JavaScript or whether you're using Java or Go. It's just to note when we move on to some of the Flight SQL stuff, there's only certain client libraries that represent Flight SQL at the moment, but this will just give you a starter for 10 in Python. So let's start off with the basics of creating an arrow table. So an arrow table is a fundamental data structure in Apache Arrow. It represents a column of data structure that consists of one or more columns of data with the same length. Each column is a homogeneous array of values of the same type, such as integers, floating point numbers, or strings. Much like Parquet, arrow tables also support a variety of advanced data types and nested data structures, such as arrays, maps, and structs, making it easy to represent complex data structures in an efficient way. So let's have a quick look at the code. So as you can see here, we import the PyArrow library as PA. So this is just the Python Arrow library. And then what we're going to do is we're actually going to start constructing the arrays that make up our PyArrow table. So in this case, we've got a PyArray called animals. This essentially contains a list of strings. We've got sheep, cow, horses, and foxes here. We then have a count within this array. We obviously have a count of each of those animals. This is of type int8. And then we also have a year. So a year when these counts were recorded, and we're saving these as an int with 16 bytes here. So once we have these arrays created, we can then formalize our table. So you can see here, table equals pa.table.from arrays. We then include each one of our array variables, and then we provide 3 names. So the names here you can imagine as your column headers. So we have animal, count, and year. And then once we print our arrow table, you can see the representation of the table stored from print out. So we have our PyArrow table, we have animal, count, and year based on those types, and then we have our arrays of data. Now, this is an extremely basic example, and in most cases, you will not be constructing an arrow table yourself. The idea here is just to give you a basic understanding of one of the fundamental structures within PyArrow. But a lot of the time, you'll be working with arrow tables that come either from Flight SQL, or you'll be converting them to another format such as pandas, where you can utilize them with other applications. But it's good to know exactly what the underlying data structure looks like for Arrow. So let's build upon this, and you can see how we can retrieve an arrow table using Flight SQL. So in this example, you can see we include a different library called Flight SQL. This also includes Arrow within its import here as well. So essentially what we do is we create a Flight SQL client. The necessary parameter that you required is the host. Sorry, I keep doing that. So the host will point at a Flight SQL endpoint. And then the rest of the parameters that you see here are optional, and we will be dependent upon the Flight SQL endpoint in use. So in this case, we'll be discussing InfluxDB IOX. So these are all the parameters required for connecting to InfluxDB IOX. So as normal, when using InfluxDB, you require a token. This is a security token created in InfluxDB. And then our metadata is where we specify our bucket. So this is the bucket where we want to be able to retrieve our data from. Buckets is a notation in InfluxDB. It's similar to a database. So once we've configured our client, we can then create our query. So essentially what we do is we call our client and we call execute. We then provide a string, which has our SQL query. Essentially what we've done here is we said, select all columns from the table machine data, where the time is now -1 day. So collect all the data relevant to now and -1 day ago. We then do a client do get. This creates a reader to consume our results. And then we ask the reader to read back all tables, to read back all data as one table. Now, we do have the ability to, if you're calling back large, vast amounts of data, to be able to increment this, so you can basically batch the number of arrow tables that come back as well. But in this case, just to keep it basic, read all is sufficient for bringing back a full pi arrow table. And as you can see here, if we print this table, this is data that I have stored in InfluxDB. So it's just an IoT example here. We have a series of columns: host, load, machine ID, power, provider, temperature, time, topic, and vibration. And this is represented as our arrow table. So now that we have our arrow table, what can we exactly do with it? What utility functions does Arrow offer that we can utilize within our client-side application? Well, the primary one that a lot of people will be using is the convert to pandas. It's the one that I use mostly as an extremely efficient way of serializing data from an arrow table into the pandas format. So essentially all you can do is just specify your table and then 2 pandas, and this will convert it to a pandas data frame. You can then sort by time and then print your data frame as usual. Other utility functions which we'll show in the demo, which are quite interesting, is the ability to save as a Parquet file and also to load as a Parquet file. Also to load an arrow table back from a Parquet file. So this is really interesting if you wanted to almost essentially create a hot load of your data. So imagine if you transformed your data, you wanted to save a checkpoint almost of that data to disk. You can save that pi arrow table as a Parquet file. You can then read that table back into memory when you want it and convert it back to pandas to carry on your analysis. So it's a really great way of checkpointing your data on your client-side applications. And it means you don't always have to requery the database as well. The final one to look at is actually Pi Arrow, or Arrow in general, has aggregation tools available to it. So in this example, you can see we have the ability to group by machine ID. So we're going to group by that column machine, and then we're then going to perform aggregations upon our data. So we're going to request the mean, max, and min for each of our machines for vibration before converting it to pandas. So let's have a look at some of this in practice. If I quickly navigate across to here, and then I jump across to here. So I've created a repository called Apache Arrow tutorial. Within here, you can find a series of examples using Pi Arrow. So let's start off with a basic one. So let's start off with saving and loading. So you can see our example that we showed here within the tutorial. We have our animal count and year. If I quickly play this, this was just loading the library in and constructing our array. Let's create our Pi Arrow table. That creates our Pi Arrow table. And if we add, so if I quickly add a print here, you can see our Pi Arrow table was formed here. Next, let's save it as a Parquet file. So if we quickly save, actually, if I delete this one first to actually show that it creates. And if we save that file, we create our Parquet file here, and then we can load that Parquet file back into memory as a pandas, as a arrow table before converting it to pandas. So if I click this, and then you can see we convert it to pandas. And then just to show you, there's also to show you as well, pandas has their own ways of reading in Parquet files as well. So it's just to show that Parquet is a highly readable format in a series of different languages as well. There we go. So moving on from this, if we then jump into our next example, which is querying. Let me make sure I've got the right example. So let's have a look at our flight SQL example so we can see exactly how the flight client works. We can see that we include our flight SQL library here. We can also include Arrow if we need to for other transformations. We specify our token as well as our host, our metadata and features. In this case, features are not needed, so I can just remove those entirely from the set. We then create our query. So we're just going to do a select all machine data from InfluxDB. It's recommended that you actually provide a time range that you want to query by, but you can just select all data from InfluxDB IOX as well. We then create our reader to consume the data. We read all, and then we can print that table. So we do that now. So it's a lot of data. So we've returned all of our machine data. We can then save that as a Parquet file again if we wanted to. And then we can load that back into memory as well, just to show a highly performant version of that data. Now, if we wanted to look at that data in 2pandas format, I quickly change this here. So if we did a table to 2pandas, and then if I remember the command correctly, I think I've got it stored here. We take the in Python display. And then if we take display.dataframe, we load that in here. As you can see, here's all of our tabular data from InfluxDB. So this is all based on that IoT use case. So this is just showing that we can convert extremely efficiently from an arrow table into pandas where we can utilize it with other platforms. So what other platforms can we utilize it with? Well, if we jump into this example here called query and graph, essentially what we're doing is we're using Plotly to visualize the same data. So as you can see, it's a similar example. We're querying InfluxDB with the new Flight SQL client library. We're running a SQL query for all columns. In this case, we're just taking from now minus that one day. We're then reading all that data in as a pandas table, converting it to pandas before turning it into a line graph. The second example that you'll see when we show the visualization is the ability to use the aggregation feature. So we have that ability to group by machine ID and aggregate to find the mean, max, and min of our vibration data before converting it to pandas. We then do some reshaping in pandas so it fits a bar graph within Plotly. And then this is just some boilerplate for actually visualizing within Plotly. So let's run this example now. And if the demo gods are with us, hopefully it should run okay. Fantastic. So if I now run this address, as you can see, we have our first representation of the data. So this is all the different machines, vibration data being run. This is the raw data from now to a day ago. And then we also have our aggregated data, which you can see here. So we're providing the mean, max, and min. And I believe that min's not being represented on screen because it's 0, which means it's just not being represented in the graph very well. So my apologies for that one, but it's definitely there. I'd have to, that's a bug for me to sort out. So I'm hoping this gives you sort of a quick overview and understanding of Apache Arrow, Apache Parquet, and Flight SQL. If I jump back over to the slides, If you want to try it yourself, simply just jump to our Influx community repo, and there is a repo there called Apache Arrow tutorial, and you can try these yourself and basically build your own client application from Arrow. There's also another project there called, I believe, Apache Arrow engine. That's another more fleshed out example of doing anomaly detection, basically creating a task engine in Arrow where we can perform anomaly detection on our time series data. So another cool use case to use with Arrow. As always, there's always community resources. Myself, Anais, and Zoe are always here to help you in the community. Chat to us on Slack community forums, as you all know. And then we have our docs from university available for self-learning purposes. And thanks very much. That's what I had for you today. So I guess we move into our live triaging. So if anyone has any questions in general about IOX or about Apache Arrow or Parquet, just drop them into the channel and we'll be more than happy to answer them. I'll give it 4 minutes, 5 minutes or so, see if anyone's got any chat. I'll check Slack as well, make sure there's nothing happening there. No worries at all. Hopefully, I'm glad you enjoyed it. It's a really cool set of open source projects to get your hands on. And so many large companies are now delving into them and providing and committing, providing code for them. So they're really cool projects to be becoming part of. What I'll do is I'll just leave this screen up in case anyone needs to get to the projects. And I don't think I also added my last, so let me quickly commit these. Examples. Awesome. I'll give it till past, and then we'll call this one finished.
So we have one question about when the OSS version will support Flight SQL. I don't know that we know, so I'm sorry about that.
Yeah, at the moment it's going it's going cloud dedicated enterprise, and then we're hoping some form of OSS. Awesome stuff. Well, just as a quick reminder at the end, so we do have our hybrid training tomorrow. It should be a lot of fun. It's a 2-hour training with a InfluxDB University badge given at the end. So if you'd like to join us, we'd love to see you there. You don't need to set up or provision anything on your own laptops if you don't want to. We provide a training instance that you can utilize. So it's a really great use case if you want to try and see how InfluxDB can be used on the edge and in the cloud as well for an IoT use case. And with that, I think I'll end the stream. Thanks all.